Did you know that some cities consume land at a rate 10 times faster than their population grows? Today we're diving into how to measure this crucial Sustainable Development Goal indicator in order to track urban sustainability. In this video, we will explore how to calculate SDG Indicator 11.31, the ratio of land consumption rate to population growth rate. This indicator helps us to measure land use efficiency, benchmark urban growth, and assess urban sustainability. So whether you are an urban planner or a geospatial analyst, this tutorial will provide you valuable insights. So let's get started. Okay, so first we are going to load the country boundary dataset from FAO. So we are loading the level 0 country dataset. So next we are going to filter to our country of interest. So for this case, we are going to use Nigeria, which is the most populated country in Africa. Next, we are going to load the FAO boundary dataset for level 1, which corresponds to the state level boundaries. Then following that, we are going to load the global 30-meter impervious surface dynamic dataset, which is created from a time series of Landsat datasets from 1985 to 2020. So this dataset is created at a 5-year time interval. Right, so we load the dataset, and then we are going to clip it to the country boundary. So for both the year 2000 and the year 2020. Next, we are going to load the Landscan global population data. So this dataset is available for population for the year 2000 and population for the year 2020. Okay, please take note that these two input variables, that is the impervious datasets for the year 2000 and 2020, and the population dataset for the year 2000 and 2020. They come from the awesome Google Earth Engine community catalog. So these datasets they are available for all the countries. So you can use this code to run it for your country of interest. Right, so next we are going to create a function that is going to calculate the ratio of land consumption to population growth rate for a given geographic region. So for this tutorial, we are calculating for the states in Nigeria. Right, so this function gets these input variables, that is the urban area in the year 2000, the urban area in the year 2020, the population in the year 2000, and population in the year 2020. Okay, so for the impervious surface layers, here this represents the urbanized land areas for the year 2000 and for 2020. Right, so for both these input variables, here the function is going to calculate the total urban area using the reduce region method here. Okay, so here it's just going to calculate the total urbanized area. Okay, so what does this function or this method do? So it is responsible for aggregating all the pixel values over the region of interest, right, for the state in this case. So that is this region, this reduced region method will calculate the sum of all the values in the region, which is defined by the state. So the sum of all the urbanized pixels in the region for that year. And the computation here uses 30 as the scale because this is the 30 meter pixel resolution that corresponds to Landsat dataset used. And here we input the maximum value. We put quite a large number so that we ensure that even in big regions, the large pixels can be handled without any errors or issues. And also, we also want to make sure that we have quite a low value here, so that we also ensure that the values don't fall below a small threshold. So this is important, so that it can safeguard us against the issues where we have some areas with small or zero values. All right, so this is the same for the urban area in 2020. We use the same function here. And for the population, again, we are using the reduced region method here for both the year 2000 and 2020 in order to determine or to calculate the total population for each state. Right, so now we are going to next calculate the land consumption rate. Right, so what is the land consumption rate? So the land consumption rate is just measuring the rate at which the urbanized land changes over these two periods. Okay, so here we are going to calculate the change in urban area over the 2 decades, and then we are going to normalize it by the urban area in the year 2000. So that is get the urban area in 2020, then subtract the urban area in the year 2000, and then divide by the urban area in the year 2000. So this is just normalizing. And the same we do with the population growth rate, which is again measuring the change in population in a defined state or urban area. So again, we get the population in 2020, subtract the population in 2000, and then we divide by the population in 2000. Right, then finally, we are going to calculate the ratio of land consumption to population growth rate. So again, this is just done by just dividing the population growth rate over the land consumption rate. And then after that, we are just going to reformat the numbers. So here we have the original, like the urban area and population area, and then the rates that we have calculated. So they are in their raw form. So we would want to reformat them to at least 3 decimal places. So this is quite good so that we don't have such big numbers with many decimal places. Right, and then we are going to have our results. After having our results, we are going to print the results to the console. So we print all the results to the console. And then following that, we are going to display the impervious surfaces for the year 2000 and 2020, which are clipped to the country boundary. And we're also going to display the population for 2000 and for 2020. And again, these are clipped to the country boundary. And then finally, we are going to display the state boundaries over the maps, over the impervious surface maps and the population maps, so that we can see the state with large changes in urban areas or large changes in population. And then finally, we are going to create a chart to display the results as a bar graph. Again, this is quite important so that it gives us a very good visual analysis. Right, this is the code. So here I've got the citations for the two data sets that we have used for the previous surface layers and the lens cut. So you can read these two papers to get more insights. Okay, so just let's run the code and then see the results. Okay, so these are the maps and the boundaries. All right, let's just check them. Okay, so we have our layers here. So this is the impervious surface for Nigeria in the year 2000, and then this is for the year 2020. So you can see there's much change, a lot of urban development. And this is the population in the year 2000, and then the population in the year 2020. Again, there's a lot of change. And if we go to the console, we can see the graph. Okay, let's just zoom in. Okay, so this is the graph showing the indicator, that is the ratio of land consumption rate to population growth rate for each state. So, for example, we have this state Bayelsa. I'm not sure if I pronounced it correctly. My apologies if my pronunciation is not correct. And it has got a very large rate here. And we have other states like Ondo. We have the Delta State. We have Edo. We have Osun. Okay, so this is just giving us the results, so you can download them as a CSV or as a graphs. Okay, and if we check, we can also see the results also that are printed here. So this is quite informative. Right, so this is the code. So please, you can use it for your country of interest. And also, if you've got your data sets, you can load them to Google Earth Engine. For example, if you've got your impervious surface, you can load them. Or if you've got your population data, you can also load them and then run this code or this script to get your results. Right, I hope this tutorial is useful for you. So please try it for your own area of interest or even province. Thank you very much for watching, and I will see you in the next one.